Hello everyone, welcome back to another video with Mr. Coder. And in today's video, I'm going to show you how to solve cake game, uh, problem 1 from USACO Silver 2024 December. So this problem, it's probably the simplest problem in the Silver division uh this time around this contest. So this is one that I solved relatively quickly, and I'll be showing you how I solved it. So, Bessie and Elsie have discovered a row of n cakes where n is less than or equal to 5 times 10 to the fifth and n is even. And it has sizes A1 through AN, so in that order. In that order is specific. It's important. That's fixed in that order. And it's from 1 to 10 to the ninth. And each cow wants to eat as much as possible. However, since they're very civilized cows, they decided to play a game to split it. The game proceeds with both cows doing alternating turns. And each turn consists of one of the following. So Bessie chooses two adjacent cakes and stacks them, creating a new cake with the sum of the sizes. And Elsie chooses either the leftmost or rightmost cake and puts it in her stash. So when there's only one cake remaining, then Bessie eats it, and Elsie eats all the cakes in her stash. If both cows play optimally to maximize the amount of cake they eat, and Bessie plays first, how much cake will each cow eat? So there's T test cases. So I'll be explaining the first one right here. So in this problem, Bessie goes first. So how will she play? How will she stack them? Well, if she stacks the 40 and 30 together, then Elsie can just take the 70, which means that Elsie will get 70, which isn't optimal. So, however, Bessie could combine 10 and 20, for example, or combine 30 and 20 as said in here. And then regardless, Elsie will take the 40, and then Bessie will combine and take the rest. So this second case, this is just in reverse. So you do either this or this. So then it would just be the same. So 60 for Bessie, 40 for Elsie. So notice that there's always going to be a fixed amount. For a certain n, there's always going to be a fixed amount of cakes that Elsie gets. So in this case for 4, Elsie only gets one cake because Bessie removes one, and then Elsie removes one, and then Bessie combines it and then takes the rest. So, this can be generalized for all cases, so that it's the amount of cakes that Elsie gets would be the number of cakes that Elsie gets would be n minus 2 over 2. Because Bessie goes first, so that removes one, and if it's 1, then uh Bessie gets it, so that removes 2. So that's why it's n minus 2 over 2. And even though in contest I considered the odd case, but n is always even, so you don't need to worry about that. So it's n minus 2 over 2. So notice that this works here or there. And it won't be any more because just like if we assume, like in this case, if like it's always optimal for Bessie to do these like middle two, because then uh Elsie won't get stacked ones together. And Bessie can't let Elsie get stacked ones, since even if she does it on the smaller end, there's still a way to avoid it. So Elsie really has the control, and Bessie has to like follow and get the remaining. So that's why that's why it is important to notice that. So for my code now, I basically did prefix sums to solve this, because notice that Elsie has control, so Elsie can take any total n minus 2 over 2. Elsie can take any from any side combination. But how do you do that efficiently? You use prefix sums, because you can't brute force it, since n is less than or equal to 5 times 10 to the fifth. But if you do O of 1 per query for each of these, then you can do it in O of n time, which is plenty enough. So I got the sum here, and then I got the prefix sums of each of the array. And then this was the part where I assumed the n was odd because I solved in 8 minutes. So I wasn't very cautious, which is something that you should pay attention to because that did waste a little bit of time noticing that, and that could be a lot more serious if in the future, like if they actually made it so odd would break it or whatever. So like this line is t totally not necessary, but this was the code that I did in the contest. So then I set the number of cakes for Elsie to have as 0, and then I went through from 0 to round inclusive. So this is the amount that you have on the left, that Elsie gets on the left side. And then you do the same thing on the right side by doing n and then n minus round plus 1. That's normal prefix sums from the right, left and right. And then you want to see the maximum of e and left plus right. So then you get the maximum of all total of these rounds. And then best use is just this total sum minus e. Notice that this could just be prefix PS of n, and that also work. So then you just print out Bessie and Elsie. So the key thing for this problem is you would normally think of how would Elsie, how would Bessie get it since Bessie's like the main character and Bessie also starts. But this problem for me was a lot easier to think about when Elsie goes first. Because Elsie has a control and Bessie has to follow what Elsie does. But if you decided to do Bessie goes first, then you'd have to minimize it because Elsie does have the control. So no, notice that like you could have just did in the middle of these two and then find the minimum and that would be Bessie's. But this way is more straightforward for me because Elsie does have the control and Bessie has to follow. So yeah, that's how you solve Cake Game, problem 1 from USACO Silver 2024 December. So yeah, thank you for watching this video. If you like this video, please like and subscribe, and I'll see you in the next video. A quick note that I will be posting a video for the second problem that I solved, and also my analysis on how I got a score of 800. So be looking for that out for that video. So yeah, thank you for watching. Bye.